Welcome everyone to this webinar. It's called Get Inspired, the Art of Logic. And today I am your host. My name is Derek. I'm the Assistant Center Director at Mathnasium of Roland Park. I graduated with a bachelor's in computer science and a bachelor's in mathematics. And I would say that background has led me to really try and find a joint combination of where the two collide. You might be trying to explore, what is computer science? Why would I go into computer science? What type of careers can you see going to computer science? What is it that computer scientists even do? Another question you might have is, how can I help someone else prepare to go into computer science? You might be interested already. You might already have some experience with coding and just love it so much that you're like, how can I learn more? Let's go to this webinar. And the last reason why you might be here is because you're here to support me, and that's cool. All right, so some potential career paths for a person with a computer science background. We got web design, so that's like creating websites, creating applications on websites, cloud services, so think like Google Drive, Google Docs, Gmail, iCloud. Literally everything nowadays uses cloud services, and that allows computers from across the world to communicate with each other really well. Another one is video game development. As a kid, you probably play some video games, and those were created by computer scientists. Someone had to code it up, make it happen. Mobile app development, so that's for games and applications on your phone. Computer security, and security is, we have computer security experts to help us make sure we stay safe. Another thing we could do is data science, and data science is almost like a combination of statistics and computer science, and that's dealing with big amounts of data. Data science is very useful nowadays because we have the computing power to be able to do a lot, and we need a lot of data to make that computation actually useful. Some other things that you might go into are computer theory, so that would be like, how can we develop new ideas in computer science? You got robotics, you got hardware, so hardware, like the physical chips inside your computer has to be made by someone, and those people are known as computer engineers, and computer science can go into that field as well. And one more thing is there's embedded systems. And if you look at a calculator, you look at a microwave, someone had to code it so that when you press the buttons, it does something correctly. So now I want to go over what it takes to be a good computer scientist. The thing I like to say is it's really the art of problem solving. What is problem solving? And problem solving is a very general phrase that we use all the time. I'm going to define it as the process of finding solutions to difficult or complex issues. I like to break it down even further. In computer science, I'm focusing on these 4 things. 1, critical thinking. So critical thinking is the analysis of facts to form a judgment. Logic, it's the reasoning tool to create a process. You need some creativity, so the use of imagination to produce a new idea. And number sense, an intuitive understanding of quantities and concepts. All 4 of these are very important to the problem-solving process. As you can see, some of these are very mathematical, and some of these you would kind of say are more liberal arts focused or more subjective. When you think about critical thinking and creativity, not everyone would immediately come to computer science, especially creativity. I want to stress creativity a lot because someone who only uses existing solutions will never develop something new for computer science. So you do want to be very creative. You want to think of new ideas, new ways that you can do certain things. You want to think outside the box where no one has ever been. Critical thinking, we always think about essays. However, in problem solving, you need to make sure you can analyze the facts properly, and that involves a lot of critical thinking. Logic is the very mathy one. Logic is just the reasonable flow from one step to the next, making sure that one leads to the next correctly. And finally, number sense, we're going to go over Number sense is a concept that Mathnasium loves to stress, and it is about just an understanding of numbers really well. And we can split it into three parts. The first part is proportional thinking. It's the ability to compare quantities of same relative size. So we're talking about multiplicative relationships. So that could be something like if a human was 6 feet tall and casts an 8-foot shadow, how big of a shadow does a 15-foot tall tree cast? And that's a proportional idea question of 6 to 8 is the same as saying 15 to blank. The next section is wholes and parts. This is the ability to partition concepts or objects into smaller ideas or parts. So that would be a question like, I hiked a trail, a 30-mile trail in 3 days. I hiked 12 miles on the first day, 7 miles on the second day. How many did I hike on the third day? So with that example, you need to notice 30 is the whole, and 12 and 7 are two of the parts, and we're trying to find the missing part. And that's something that we also work on at Mathnasium, is trying to get that wholes and parts idea down, of being able to recognize which one is missing. Is it a missing whole or a missing part? And how can we solve that? The last facet of number sense is counting. And counting is the ability to count from any number, to any number, by any number, forwards and backwards. So that's a mouthful. You can think of it as an example of, we're going to count from 27 to 3 by fours. So that would go something like 27, 23, 19, 15, and so forth. And the point of today's webinar is to go over task analysis. And task analysis is the way that we can practice problem solving. It is the process of breaking a skill down into smaller and more manageable components. Right off the bat, this already sounds like wholes and parts. We're splitting things into smaller chunks, more manageable chunks. You can think about critical thinking. We need to know how to split up into multiple parts. The question is, how does this help us problem solve? The critical thinking, you might be asking questions like, what are my resources? What should my result be? Any analysis of what facts are given would involve critical thinking. Next, logic. So do my steps flow from one to the next properly? When you're doing task analysis, you want to make sure the smaller tasks you have go in the correct order so that they lead to the next one. If you skip a step, then someone else looking at your steps will get lost and confused and won't be able to follow. The goal is that if you are descriptive enough with your steps, then anyone can follow your plan and make it happen. In the bottom left, again, creativity is so important. What's another way to split the task? Is this the best way that we can do it? So when you task analyze, you will always be thinking, how can I make this better? How can I make it faster? How can I make it more efficient? You need creativity to think of a different way to split up into smaller chunks. And finally, number sense. And the questions we can ask with this is, how can we use smaller steps? What can we do if we have more or less resources? So that's an idea of proportional thinking. For example, if you were task analyzing tying your shoes, what do we do if we have 2 pairs of shoes to tie? Well, you could do the same thing twice, but what if you could do it more efficiently? So in those types of scenarios, we're talking about proportional thinking and also talking about what can we do with those additional resources. Alrighty, and now we're gonna have a little bit of practice. I'm gonna start off with building a peanut butter and jelly sandwich. Ironically, I've never had one, but I still know how to make one, hopefully. So the first step we're gonna do is we're gonna go grocery shopping. Grocery shopping, we get our materials and then we can gather our ingredients. After we gather our ingredients, we're gonna assemble the sandwich, and then we're gonna serve the sandwich, and then we're gonna enjoy that sandwich. It's gonna be real good. That's an example of task analysis on a bigger scale. So now we're gonna zoom into the gather ingredients portion. And I wanna know what are some ideas that you guys have of what are some steps we need to gather ingredients. I see a good answer of digging in the back of the fridge for some jam. Yep, we definitely need to grab that jam. I got a creative one, bake the bread. Um, Baking the bread definitely takes a lot of work, but that bread's gonna be even more delicious. So far we got jam, we got bread. What else do we need to make a peanut butter and jelly? Peanut butter. Yes, good job, guys. Looking for the peanut butter. Make sure we grab peanut butter, jam, and bread. A knife. A knife is very useful. We're going to need a knife to spread that peanut butter and jelly. If we're going to serve our peanut butter and jelly sandwich, what do we need to serve it on? A plate. There we go. So a plate to serve our peanut butter and jelly. A knife to spread the peanut butter and jelly. Only the finest of China to serve my peanut butter and jelly on. That's a good one. So the steps that I came up with before our presentation, the first thing we're going to do, grab the bread. We're going to grab the peanut butter and grab the jelly. Some people like to split two different knives when you spread the peanut butter and jelly so they don't cross-contaminate. And then finally, we can grab a plate. So we need bread, peanut butter, jelly, a plate, and one knife or two knives. We're going to practice some more. Now we're going to do the grocery shopping portion. What are some steps we need to do to go grocery shopping? Convince my mom to go to the store. Yes. If you cannot drive yourself, have your parents drive you. Wear a mask, so important in this particular time. I see making a list and having a list, great idea. We need to make sure that we get everything on that peanut butter and jelly materials. We need money. Yes, can't go to the store without some money. So now, my final step that I want to go over is I want you guys at home to task analyze assembling, serving, and enjoying the sandwich. And you can share your answers with us on Facebook or Instagram, literally any medium we want. I would love to hear your answers. I already love seeing the answers that you guys are giving right now. They're creative. They use your critical thinking. Baking bread, very creative, very out there. You wouldn't normally think of it, and that's exactly what you need to be a good task analyzer and a good problem solver. But a few more things about how we can keep learning. So the first thing is, if you're a beginner to computer science, you haven't done very much, my favorite tool is called lightbot.com. And lightbot.com is an educational game for learning software concepts. And this is on Windows, on Mac, it's on iOS, it's on Android, it's on anything you could possibly think of that's connected to the internet, of course. It is a great tool. I would recommend it for beginners, intermediates, advanced, and even I would play it now if I had time. Next one, Scratch is a block-based programming language. It's available on web browsers for Windows and Mac. And what I mean by block-based is it's a lot more simpler to do than like looking at a whole bunch of text. If you think of computer science in like movies and pop culture, you'll usually see like tons of lines in this black and white screen. This is not like that, not as daunting, not as scary. Scratch is a very nice tool to just get started into it. And finally, if you are an advanced student and already have a little bit of experience, I would say go to Python Turtle. Python is a specific programming language that you will see the black and white. And Turtle is a simple library that's good for beginners. And there's a lot of tutorials for that specific library on YouTube or realpython.com. So all three of these tools are very useful to keep learning computer science. I would say Lightbot is definitely my favorite. That's why it's big and in the middle. Thank you for joining me. We have the links here for Instagram, Facebook, our website, my website. I can take any questions that you have now as well.
We do have a question to start off with.
Right.
So someone asked, how do you check that you are on the right track while in the middle of your tasks?
my best suggestion for you is plan before you do your tasks. If you plan it out beforehand, then you'll know what each task is supposed to do. The idea is that after you task analyze, then you start doing your steps one by one. What is the minimum level of math you think someone needs in order to be successful in computer science? I would say it's not about the specific math skill, but rather the idea of number sense. That's the only part that actually uses math, is that number sense portion. And you can be great with number sense and still be in pre-algebra or sixth grade math.
But I'll add, you can start this at really any age. Like I know my nephew is, I think, in second grade this year, and he does a lot of the different coding games and the activities at home. So that's something that you can start whenever you want to.
Yeah, for sure. I see. What can kids do to practice this kind of thing, of thinking without staring at a screen all day? So, right, if you don't want to play Lightbot, if you don't want to do Python or Scratch, then I would say when you see anything that you need to do, take a moment and task analyze and see if you can break it down into different steps. For example, something simple like going to the store. I can break it down into, I need to open the door, I need to grab my keys, I need to lock the door, I need to walk to my car, then I need to unlock my car, sit down in the car. Oh, I forgot to open that door. So already there, we've got like 6 or 7 steps. We can definitely put more in as well.
One of my favorite things I've seen is this is actually something I saw at a workplace like training meeting where they had one employee give directions to the other employee and that they couldn't do anything the person didn't say. That was exactly that. Like they might have forgotten to say open the door. So if they say go outside and the door's closed, like it creates an awkward situation. So that kind of game can be really fun that you can play with your kids.
You can also play that with friends, and you can have them try and give you tasks and you will purposefully do them wrong. So like, for example, if someone was building a peanut butter and jelly and someone said, you need to spread the peanut butter, then I would just like spread it on my face and then be like, ha, I spreaded peanut butter, look at me.
I don't recommend that step, but something else you can do is, I know we have in Virginia, so I know Derek's in Maryland, but we're kind of spread out a little bit. In Virginia, there's a group called Code Virginia that will mail you different like coding projects that you can do that are things like ciphers and different things that are not virtual, and so you're not staring at that computer screen. So I'm certain there are programs like that all over, no matter where you're from. Ooh, we do have a new question. Are there any board games you recommend? We could be here for 5 more hours talking about board games.
Yeah, there's so many board games.
So what's your favorite board game that kind of matches this?
I really like a game called Hanabi. It's a cooperative game where you don't get to see your own cards. So it's cooperative in that everyone has different information, and that makes it really difficult. But that's what also makes it so fun and challenging. And that challenge is where you really use that task analysis. You think about who's going to do what, who's going to say something else on their next turn.
So one of my favorites, this is more mathy, but I think it still fits, is Prime Climb, where you have to, so you take the number that you're on, and then you roll 2 dice, and you can add, subtract, multiply, or divide your numbers, and you have to decide kind of which order you want to go in and which operation comes first. So I feel like that still gives you a good thought about how, like what you can do to get to where you're going. But I'm also certain we could just come up with a huge list. Everybody,
Yeah,
like all we do is play board games.
I love board games.
Thank you so much for coming out today and seeing our webinar.
Thank you.